Every single person watching this right now is alive because of one thing. Not language, not tools, not even our big complicated brains. Fire. Humans are the only species on this planet that has ever figured out how to create and control a flame. Every other animal on Earth runs from it. We run toward it. We cook with it. We build with it. We wage war with it. We gather around it when we need comfort. And the crazy thing is, we almost never stop to think about how strange that is. 8 billion people walking around with this ability baked into our culture, our survival instincts, our very biology, and almost nobody talks about the moment it all started. That moment happened on the grasslands of Eastern Africa, when a small, terrified primate made a decision that no animal had ever made before. It walked toward the flames instead of running away. The oldest hard evidence we have puts deliberate fire use at roughly 1 million years ago. By the time our ancestors figured out how to create fire on their own, hundreds of thousands of years later, they had already become a completely different species because of it. Their teeth had changed. Their stomachs had changed. Their brains had nearly doubled in size. And none of it would have happened without that first encounter with flame. How does a small, vulnerable primate with no claws, no fangs, no venom, and no armor become the most dominant creature this planet has ever seen? It starts with a spark, and not even one they made themselves. Picture Eastern Africa, about 2 million years ago. The landscape is enormous. Open savanna stretching in every direction, dotted with clusters of acacia trees and cut through by riverbeds that flood during the wet season and bake dry under the summer sun. The air smells like dust and dried grass. Herds of ancient antelope move across the horizon. This is home for Homo erectus, one of our earliest direct ancestors. They stand upright, roughly 5.5 feet tall, with longer legs than the hominids that came before them, and brains about 2/3 the size of ours today. They are social. They travel in groups of 20 to 40, communicating through gestures and simple vocalizations that are nothing close to language. They use basic stone tools, mostly sharp flakes chipped off larger rocks, good enough to butcher a dead animal or scrape marrow from a bone. But make no mistake, they are far from the top of the food chain. Lions, hyenas, leopards, saber-toothed cats, and wild dogs all hunt in this same territory, and Homo erectus is absolutely on the menu. They have no natural weapons worth mentioning. No claws that can slash, no teeth that can kill, no speed that can outrun a predator in a sprint. Their only real advantage is numbers and alertness, and even that only works during the day. At night, these hominids huddle together in the open or squeeze into rocky overhangs, alert to every sound in the darkness, because once the sun sets, they are almost helpless. The night belongs to predators with better night vision, sharper senses, and no fear of the dark. For millions of years, this is how it works. The day is yours, the night is theirs. Then something happens that changes everything. A dry lightning storm rolls across the savanna. Bolts strike the parched grass, and within minutes, fire rips across the plains. Every animal reacts the same way. Antelope stampede, birds scatter, hyenas bolt for the tree line. Everything with a pulse flees from the flames in blind panic. But a few of these early humans do something different. They stop, they watch. Maybe it is curiosity, maybe it is something else entirely, but instead of running, they observe the fire as it moves through the landscape. And once it passes, they walk into the burned ground and discover something that will alter the course of their species forever. The animals that could not outrun the flames are lying there, partially cooked by the heat. The meat is softer than anything they have ever eaten. It tastes different. It is easier to chew, easier to swallow. Their bodies can extract more energy from it with less effort. This is not a conscious decision. They are not sitting around discussing nutritional science, but their bodies know the difference, and they will keep coming back to the aftermath of fires for generations. This is where the story takes a turn nobody expected, because for a very long time, our ancestors did not make fire. They found it, they scavenged it. Every encounter with flame was accidental, the byproduct of a lightning strike or a volcanic eruption or a brush fire sparked by dry heat. And for hundreds of thousands of years, that was enough. Early humans learned to approach natural fires instead of fleeing from them. They figured out that a burning branch could be carried from one place to another without dying out, as long as you shielded it from the wind. They realized that if they fed a flame with dry grass and dead sticks, it would keep burning. They noticed that certain types of wood burned longer and hotter than others. Slowly, through trial and error repeated over countless generations, maintaining fire became a skill. It was probably passed from one member of the group to the next through observation and imitation rather than any kind of verbal instruction. There might have been designated firekeepers, individuals whose job was to watch the flame, feed it, transport it when the group moved camp. We do not know for sure, but the responsibility would have been immense. Imagine the pressure. If your group's fire went out, you could not just strike a match. You could not rub two sticks together because nobody had figured that out yet. You were back to square one, waiting for the next lightning storm, the next brush fire, the next lucky break from nature. That might take weeks, it might take months, and in the meantime, you were eating raw food, sleeping in the cold, and listening to predators circling your camp in the dark. Keeping that flame alive was not a convenience. It was the difference between thriving and barely surviving. The earliest hard evidence for controlled fire use comes from Wonderwerk Cave in the northern Cape province of South Africa. In 2012, a team of researchers led by Francesco Berna at Boston University published findings that rocked the field of paleoanthropology. Deep inside the cave, about 30 meters from the entrance, they found layers of ash and fragments of burned bone mixed with stone tools. The dating placed these remains at roughly 1 million years old. That is staggering. 1 million years ago, someone, almost certainly Homo erectus, was building and maintaining fires inside a cave. Not out in the open where a wildfire might explain the ash, but deep inside a sheltered space where fire could only exist if someone brought it there and kept it going. The fragments of burned bone showed heating patterns consistent with campfire temperatures, not wildfire. And the ash deposits were concentrated in specific spots, suggesting repeated use of the same fire pit over time. This was not an accident, this was behavior. But here is the detail that everyone missed at the time. The real revolution was not the fire itself, it was what fire did to the food. And this is where a Harvard primatologist named Richard Wrangham enters the story with an idea so simple and so radical that it took decades for the scientific community to fully come around to it. Wrangham proposed what he called the cooking hypothesis. He argued that the control of fire, and specifically the cooking of food, was the single most important event in human evolution. Not stone tools, not walking upright, cooking. His logic went like this. Raw meat is tough. Raw plants are fibrous and often toxic in large quantities. Chewing and digesting raw food takes enormous energy and time. Chimpanzees, our closest living relatives, spend roughly 6 hours a day just chewing. But cooking breaks down the cellular structure of food before it even enters the mouth. Proteins denature, starches gelatinize, tough connective tissues soften. The result is food that delivers far more usable calories for far less digestive effort. And Wrangham argued that this caloric surplus is exactly what funded the expansion of the human brain. Think about it. The brain is the most energy-hungry organ in the body. It accounts for roughly 2% of body weight, but consumes about 20% of all the calories you burn in a day. That is a wildly disproportionate ratio. No other organ even comes close. Growing a bigger brain requires a massive energy investment, and that energy has to come from somewhere. You cannot just add a bigger brain to an existing body plan and expect it to work. Something else has to give. In most primates, the gut is the energy hog. Large intestines, complex digestive tracts, all designed to extract nutrients from raw, low-quality food. A gorilla's gut is enormous relative to its body because it spends all day eating raw leaves and bark and needs that digestive machinery to squeeze out enough calories to function. But the fossil record shows something bizarre happening in the Homo erectus lineage. Their guts got smaller, significantly smaller. Their teeth got smaller too, and their jaw muscles weakened. The bony ridges on the skull where heavy chewing muscles once attached started to shrink and eventually disappear. And at the exact same time, their brains got dramatically bigger. Wrangham argued that cooking is the missing variable that explains all of these changes simultaneously. Cooked food meant you did not need a massive digestive system anymore. The energy that used to go to maintaining a long, heavy, metabolically expensive gut could now be redirected upward to the brain. Smaller teeth and weaker jaws were no longer a death sentence because the food was already soft. Natural selection started favoring intelligence over raw digestive power. And that trade, that biological bargain, only works if you have fire. Take away fire, and the whole equation collapses. You need the big gut again. You need the big teeth. And the brain goes back to being a luxury you cannot afford. Now, this was not some overnight transformation. We are talking about changes that unfolded across hundreds of thousands of years, but the trajectory is clear in the fossil record. Homo erectus had a brain roughly 60% the size of modern humans. By the time Homo heidelbergensis appeared around 700,000 years ago, brain size had jumped significantly. And by the time anatomically modern Homo sapiens showed up around 300,000 years ago, the brain had nearly doubled from the Homo erectus baseline. The gut, meanwhile, had shrunk proportionally. We have the smallest digestive tract relative to body size of any primate, and we have the largest brain. Wrangham's argument is that you cannot have one without the other, and you cannot have either without fire. But the cooking hypothesis only tells part of the story. Fire changed more than just our biology. It reshaped how we live together. And this part of the story does not get nearly enough attention. Before fire, the usable day ended at sunset. Once it got dark, you stopped moving, you stopped foraging, you stopped doing anything productive, and you tried not to get eaten. The night belonged to predators, but fire flipped that equation. A campfire pushes back the darkness. It keeps predators at a distance because almost every large carnivore avoids flame instinctively. Suddenly, you have these extra hours. Hours where you are safe, warm, fed, and have nothing urgent to do. What do you fill that time with? You talk. Anthropologist Polly Weissner spent years studying modern hunter-gatherer groups, specifically the Jew Hoansi people of the Kalahari Desert in southern Africa. To understand how firelight conversations differ from daytime interactions, she recorded and categorized hundreds of hours of conversation in both settings. What she found was striking. During the day, about 80% of conversation was practical and often tense. Who is hunting where? Who is gathering what? Complaints about someone not pulling their weight, negotiations over food sharing, minor disputes about territory. Functional, sometimes confrontational stuff. But at night, around the campfire, the content shifted dramatically. Roughly 80% of nighttime conversation was storytelling. Myths about how the world began, legends about ancestors, detailed accounts of hunts gone wrong and narrow escapes, tales about distant relatives, faraway places, and strange encounters. People laughed more, they sang, they danced. Arguments from the day dissolved. The campfire was not just a source of heat and light, it was the original social network. It was therapy. It was entertainment. It was church. All rolled into one, long before any of those concepts had names. Pay attention to this, because it explains everything about what came next. Language itself may have evolved partly in response to these nighttime gatherings. Not just the ability to make sounds, which many primates can do, but the ability to talk about things that are not physically present. Abstract thought, hypothetical scenarios, plans for the future, stories about the past. The campfire created a context where this kind of communication was not just useful, but necessary. You needed language to tell a story. You needed imagination to follow one. And over thousands and thousands of generations, the groups that were better at this, the ones who could plan more complex hunts, share more detailed knowledge, and build stronger social bonds through narrative, those were the groups that survived. In about 100,000 years, Homo sapiens would look back on this period and not even recognize how much had changed. But in the moment, it was invisible. Just one more night around the fire, one more story told in the flickering light. And then came the breakthrough that might matter more than any other single moment in human history. At some point, and we still do not know exactly when or where, a human being created fire from scratch. Not captured it from a lightning strike, not carried it from a brush fire, not borrowed it from a neighbor's camp. Made it. Out of nothing but raw materials and effort. The most likely method was friction. Take a dry stick of hardwood, press the tip firmly against a flat piece of softer dry wood with a small notch carved into it, and spin the stick rapidly between your palms. Or better yet, wrap a cord around the stick and use a bow to spin it faster and longer than your hands alone ever could. The friction generates heat. The wood dust accumulates in the notch and begins to darken. The heat builds and builds until the dust starts to glow. A tiny orange ember, no bigger than a pea. Blow gently on that ember, transfer it carefully to a bundle of dry tinder, shredded bark, or dried grass, and nurse it with steady breath until the tinder catches. And then you have flame. It sounds simple when you describe it in a few sentences. It is not simple at all. It requires knowledge of which woods work and which do not. It requires dry conditions. It requires considerable physical effort, sustained over several minutes. It requires patience and fine motor control. And most importantly, it requires the understanding that fire can be produced through this process in the first place, an insight that took our species hundreds of thousands of years to arrive at. But once someone figured it out and taught it to others, the implications were world-altering. Fire was no longer something that happened to you. It was something you could summon whenever you needed it. That single shift from passive user to active creator is arguably the dividing line between our ancestors and us. The archaeological evidence suggests that habitual fire creation probably became widespread somewhere between 400,000 and 200,000 years ago, though some researchers argue it could be older. What we know for certain is that by the time modern Homo sapiens began migrating out of Africa around 70,000 years ago, fire-making was a core technology, and it had to be. Because where they were going, survival without fire was physically impossible. The first human groups to cross into the Levant and push north into Europe and Central Asia encountered something their species had never dealt with at this scale before. Cold. Real cold. Not a chilly night on the savannah, but months of below-freezing temperatures, ice, wind, and snow that buried the ground for half the year. Winter in Ice Age Europe was brutal beyond anything a tropical primate was designed to survive. The plant foods that had sustained African populations for millions of years simply did not exist in these latitudes during the cold months. Game animals migrated or hibernated. Daylight shrank to just 8 or 9 hours. Without fire, Homo sapiens would have frozen to death within days of their first northern winter. Full stop. There is no way around this. We are tropical animals, wearing the wrong body for these environments, and fire is the only reason we survived. Every campsite excavated from this period shows evidence of hearths, carefully constructed fire pits lined with stones to retain heat and reflect warmth back into shelters made of animal hides, stretched over mammoth bones or wooden frames. The engineering was surprisingly sophisticated. Smoke from the fire helped preserve meat for long-term storage, drying it into something that could last weeks instead of days. Fat rendered from animal kills was burned for additional light and heat. Fire was not a luxury in these frozen environments. It was oxygen. It was the margin between life and death, and everyone in the group knew it. And fire did something else during this period that we rarely think about. It changed the landscape itself. Early humans discovered, probably through accident at first, and then through deliberate experimentation, that controlled burns could clear dense brush, drive game animals into kill zones, and promote the growth of fresh young plants that attracted grazing prey back to specific areas. This is not accidental. This is land management. This is ecological engineering on a continental scale. Tens of thousands of years before the first wheat was planted, before the first sheep was penned, humans were already reshaping their environment to suit their needs, using nothing but flame, The Australian Aboriginal peoples practiced what researchers call fire stick farming for at least 50,000 years, systematically burning sections of the bush in rotating patterns to encourage new growth, clear pathways, and maintain the biodiversity of the landscape. They understood something profound about the relationship between fire and life. Burned ground does not stay dead. It regenerates faster and more abundantly than unburned land. The ash returns nutrients to the soil. New shoots push up within weeks, and those new shoots draw kangaroos, wallabies, and other game animals right to where the hunters want them. The land and the flame work together in a cycle, and the humans orchestrated the whole thing. This was not destruction, it was cultivation, just without the crops. By the time the first agricultural societies appeared around 12,000 years ago in the Fertile Crescent of Mesopotamia, fire had already been central to human life for 1,000,000 years. Farming introduced new applications, firing wet clay into hard, waterproof pottery, smelting copper ore into metal tools, and eventually into bronze weapons that changed the nature of warfare, clearing vast tracts of forest to make room for wheat fields and barley crops. But these were extensions, elaborations, of a relationship that was already ancient beyond comprehension. The potter's kiln is a descendant of the campfire. The blacksmith's forge is a descendant of the campfire. The coal furnace that powered the Industrial Revolution, the internal combustion engine that put the world on wheels, the rocket engines that launched humans into orbit above the Earth, every single one of these technologies traces a direct, unbroken line back to that first hominid who watched a lightning fire burn across the African savanna and made the decision to walk toward it instead of away. What makes this story so different from every other animal story on Earth is not just that we used fire. Plenty of species interact with the aftermath of fire. Some birds of prey in Australia have been observed picking up burning sticks and dropping them in dry grass to flush out rodents. But no other species has ever maintained fire, let alone created it. The gap between noticing fire and controlling fire is enormous. And the gap between controlling fire and generating fire is even bigger. Each step required a kind of thinking that simply did not exist before. The ability to observe a process, remember it, replicate it, and teach it to someone else. That is culture. That is cumulative knowledge. That is the foundation of everything humans would eventually build. And then there is the dimension that is hardest to measure but maybe the most important of all. Fire changed how we think about meaning itself. The earliest evidence of deliberate burial, one of the first signs that a species has developed some concept of death, ritual, and perhaps an afterlife, coincides roughly with the period when fire use became universal among Homo sapiens. In Campfires cave in modern-day Israel, researchers found that early Homo sapiens buried their dead with red ochre pigment smeared across the bones and carefully placed seashell ornaments roughly 100,000 years ago. The cave shows extensive evidence of fire use, hearth after hearth, layer after layer, spanning thousands of years of occupation. At Skull Cave nearby, similar burials appear alongside the same kind of hearth remains. Further back in time, deep in the caves of South Africa, the earliest known examples of symbolic art and geometric patterns scratched into pieces of ochre at Blombos Cave around 77,000 years ago also come from sites saturated with evidence of fire. We cannot prove a direct causal link. We cannot say that fire caused humans to start thinking about death and meaning and beauty. But the connection is very hard to ignore. Sitting around a fire in the darkness, watching the flames shift and pulse, listening to stories told by people whose faces flicker in and out of the light, watching shadows stretch and dance across cave walls, this is a profoundly contemplative experience. It changes the quality of attention, it slows things down, it invites reflection in a way that the bright, busy, survival-focused daylight never does. Fire at night is the oldest form of meditation. It is the original theater, and it would eventually lead to cave paintings, to carved figurines, to religion, to philosophy, to every abstract system of thought that humans have ever produced. Standing back and looking at all of this, the scale of what fire did is almost impossible to overstate without sounding ridiculous. It changed our teeth. It changed our guts. It grew our brains. It extended our waking hours. It gave us language, community, and culture. It let us leave Africa and colonize every continent on the planet, including frozen wastelands where no tropical primate had any business surviving. It gave us the ability to reshape entire landscapes, forge metals out of rock, fire bricks out of mud, and eventually launch ourselves off the surface of the earth and into space. Every single thing that separates us from other primates on this planet connects back to fire in some way. Strip it all away, the cities, the technology, the philosophy, the art, and you are left with a creature sitting beside a flame in the dark. That is who we are, at the most fundamental level. We are the fire species, not because we discovered it, since fire existed for billions of years before the first hominid ever drew breath, but because we were the only ones curious enough, stubborn enough, and reckless enough to grab it, hold on to it, and refuse to let go. The next time you light a candle, start a grill, or sit around a campfire on a summer night, remember that you are performing the oldest human ritual in existence. Older than language, older than art, older than civilization. Somewhere in the deep past, a small, frightened primate watched a wildfire tear across the African grassland, and instead of running, they stayed, they watched, they learned, and they changed the world forever. If this story gave you a new way of thinking about where we came from, hit subscribe and drop a like so more people can find it. And let us know in the comments, what do you think was the single most important moment in human history?